Actually, I already covered concentration term up to molality. So okay, here it is, the list of concentration term. Are you aware of this concentration term? Like, is the screen shared?
Yes, sir.
Weight by weight percent, weight by volume percent, volume by volume percent, mole fraction, molarity, molality. I covered up to molality. Do you have already? Do you already know about this concentration term?
Yes, sir.
Okay. Can you tell me? Have you studied normality?
No, sir. We only did the molality.
Okay, up to molality, you know, right?
Yes.
Uh, Alia, Alia, am I audible to you? Okay, she's disconnected. Now, I'm going to give you a question on molarity and molality, since other students will join soon. So I just want to know how much you know about molality and molarity. So first question is on molarity, 4.9% weight by volume, H2SO4. Calculate molarity. And the second question is basically 10% weight by weight, NaOH. Calculate molality. So these two questions are based on formula and very easy. Can you solve it or should I help you?
To solve it.
Okay, just take your time. And then after joining more students or the student from last class, sorry, I was just disconnected. Okay, Hamza, you just joined. Hamza, am I audible to you?
Yes, sir.
Okay, so I just gave a question on molarity and molality too. Then we will start. Today's topic is basically normality. So first of all, you are going to solve this question and then we will start the topic normality. So, so Fatima, are you able to solve this or this?
I'm still doing the first, the second one.
Okay, what about the first one? Are you done with the first one?
Yes.
What is your answer for the first one?
0.5.
0.5 what? Kilogram? Or,
Capital and
what? What is its unit? That is more important.
M.
M.
Capital M.
Can you tell me what does this M stand for? This is the very basic question. If you know, please let me know, or if you don't know, please let me know. M, that represents molarity. But if their question is what is the unit of molarity? Can you tell me the unit of molarity? Hamza, can you tell me the unit of molarity?
Yes, sir. 1 minute.
Yes.
Is it mole by
Mole by, very good. Mole by
Mole by liter, sir.
liter. Since we all know the, let's discuss the first one. So for molarity, first of all, there is 4.9% weight by volume. What does this means? It is very important to write an equation about it. Okay, so you can see 4.9%. That means 4.9 gram of solute. Solute is basically H2SO4 in 100 ml solution, right? 100 ml solution. This is given. And now what we need to calculate is molarity. And basically molarity is equal to number of moles of solute upon volume of solution in liter. Now see, this is number of moles of solute, in which number of moles of solute is not given directly, but we can calculate number of moles of solute using the formula given mass upon molar mass upon volume of solution in liter. Now see, what is the given mass? 4.9 gram. Can anyone tell me what is the molar mass of H2SO4? Very easy question. I think you have calculated. What is the molar mass of H2SO4? Fatima?
98.
Sir, 18. 18.
98. 98. Hamza, 18 is the molar mass of water. And we are talking about H2SO4. So you can calculate atomic mass of hydrogen is 1, but there is 2 hydrogens. So we are going to multiply it by 2. Plus what is the unit of sulfur? Atomic mass of sulfur, that is 32. Plus what is the atomic weight of oxygen? That is 16. But there are 4 oxygens. So multiplying by 2, 4. 2 plus 32 plus 16, 4 is 64. So if you are going to add it, it will be 98. Now, what is the volume of solution? 100 ml. But we need to convert the ml into liters. So divided by 1000. Now we are just going to calculate it. 4.9 upon 98 into 1000 upon 100. Now 10, 10, 10, 10 will be cancelled. And if you are going to remove this decimal, 10 will be multiplied in denominator. Again, this will be cancelled. And this 49 to the 98. So we are left with 1 by 2, which means 0.5. The answer is very good. Correct, Fatima. But it is important to learn the unit also. You just said 0.5 m, that is very good. But what is its unit? You can see molarity is equal to number of moles upon volume of solution in liter. So what is the unit? Moles in numerator and liter in denominator. And in short form, moles per liter is replaced with capital M. That's very good. The answer is correct. Is that clear, everyone? Fatima, Hamza?
Yes, sir.
Okay, thank you so much. Now, come to the second question and let me know if you are able to solve it or not. Should I start explaining?
Yes, sir.
Okay. Hamza, what about you?
Yes, sir.
Okay, so the question is very simple, 10% weight by weight. See, whenever a question is asked, 10% weight by weight, NaOH, it is given, and we need to calculate molality. First of all, whatever is the given, just focus on that. And whatever is asked, just write the formula. You know that 10% weight by weight means 10 gram of solute present in 100 gram of solvent. See, so 100 gram of solution. 100 gram of solution. Does everyone know about this? How to write? What does this percent weight by weight and what
Yes.
weight by volume and volume by volume? Fatima, are you aware of this?
Yes, sir.
Okay. So see, solute is basically NaOH. What we have given is 10 gram of NaOH. That means mass of solute is given, and also mass of solution is given. Now what we need to calculate is molality. Now going to write the formula of molality. Molality is equal to, you know that, number of moles of solute upon mass of solvent in kg, upon mass of solvent in kg. Now see, number of moles of solute. Can we calculate number of moles of solute with the help of mass? Yes, we can easily calculate, because number of moles has one of the formula. For finding number of moles, we have three formula. The first one is given mass upon molar mass. The second one is given volume upon molar volume, which is 22.4 liter. And the third formula for finding number of moles is given number of particle upon Avogadro number. According to the situation, or according to the given uh, according to the problem in which whatever is given, like if mass is given, we are going to use this formula. If volume is given and we need to calculate number of moles, we are going to use this formula. If number of particles are given and if you need to find number of moles, then we will use this formula. So you can see mass of solute is given, so it's simple to understand that we are going to use this formula. Is that clear, everyone?
Yes, sir.
Now see, given mass upon molar mass upon mass of solvent in kg, mass of solvent in kg. It's clear that number of moles of solute can be easily find out with the help of this. But in denominator, its mass of solvent we need to calculate first. Now see, we know that solute plus solvent is equal to solution. So I can also write mass of solute plus mass of solvent is equal to mass of solution. So in short, I can also write with the help of this, mass of solute is thus 10 gram, and mass of solvent is mass of solvent, and mass of solution that is given 100 gram. So mass of solvent I just calculated is 100 minus 10, which means mass of solvent is basically 90 gram. Is that clear? Is that clear, everyone? Fatima?
Yes, sir.
Now see, given mass, applying this formula, given mass is basically 10 gram and molar mass of NaOH. Have you calculated molar mass of NaOH? That will be 40, you can calculate. And mass of solvent, here it is 90 gram, but we need to calculate it in kg, so divided by 1000. Now going to simplify it, simplifying it, 10 by 40 into 1000 upon 90. Again, if you are going to cancel all this, 0 0 0 0, so it will be you can see 100 upon 4 into 9. So you know that 425 is a 425 is 100, 25 into 4 equals to 100. And now going to see what it is left with. So molality is equal to basically 25 by 9. And what is its unit? Moles per kg. So in denominator it's moles, and in numerator it is mass in kg, so moles per kg, or we can also write 25 by 9 small m. This small m represents molality. I hope this is clear with both of you. If you still have any doubt, please ask me. Hmm. Hamza, is there any doubt in this?
No, sir.
Fatima?
No, sir.
Okay. So I'm going to give another question on this, similar to this question. Then I I will come to know about, have you understood it really, or can you apply the formula? Please let me know when you are finished with this. Oh, sorry.
Done, sir.
Thank you. Hamza, are you done?
Yes, sir.
Thank you. So I'm going to give you another question on the same topic. This is basically 10% weight by weight CaCO3 in aqueous solution. It can be written or it cannot be written. It can be given. It may or may not be given. Calculate molality. Please do this question in the same way that we just uh, calculated about the molality of NaOH. Any answer?
Yes, sir. 10 by 100 by 90.
Oh, just solve it more. What is
Yeah, I'm
this answer?
solving,
10
sir.
by 100
By
by
90. I'll solve
just
it more.
solve. Okay. Fatima?
Sir, 0.001.
This is the molality you got. Fatima, is there any answer from you?
I got 2.9.
Okay. Okay, just let me check. 10% weight by weight. What does this mean? This means basically 10 gram of solute. That means 10 gram of CaCO3 in 100 gram. I just wrote it wrong. 100 gram solution, right? Now, molality is equal to number of moles of solute that we can easily calculate upon mass of solvent in kg. Now see, what we need to do, number of moles, that is given mass upon molar mass upon mass of solvent in kg. Given mass is 10 gram. What is the molar mass of CaCO3? Hamza,
100.
what is the 100? Very good. Have you taken 100, Fatima? You also?
Yes, sir.
Thank you. Mass of solvent. Can you tell me the mass of solvent? Anyone?
10. I mean 90.
Fatima, what is the mass? Very good. Hamza. Fatima, mass of solvent is, you are just not audible. 90. Because mass of solution minus mass of solute will be equal to mass of solvent and divided by 1000 because we need to convert it into kg. Uh, did you do that, Hamza? Did you convert mass in kg? Yes or no?
No, sir.
So that's your mistake, because it is written in the formula or in definition that molality is equal to basically number of moles of solute per unit uh, mass of solvent in kg. So it is basically 10 by 100. I think,
Sir, I didn't understand.
okay. I think your answer is right, Fatima. So you
Sir,
can calculate.
why do we have to convert it?
This is just, wait a minute. I'll just let you know. Did I do something missed wrong? Wait a minute. I'll just tell you. This is 10 by 100. Okay. And this 1000 will be here. And then 90 will be here. So now we can easily cancel these zeros. 0, 0, 0, 0, 0, 0. So this is basically 10 by 9. So answer is not 2.5. I don't think 2.9 answer will be. It is basically 10 divided by 9. That is equal to 1.2. So is this clear? Fatima, what's your mistake? Fatima. So Hamza, by the definition, you can see either we define molarity, molality, or normality. The volume we take is defined by its definition. If you are going to take it in milliliter, you just have to uh, write the unit ml, like moles per ml you are going to calculate. By the reference, it is just understood that whenever we are going to calculate molarity, it will be in liter, and when we calculate molality, it will be in kg. Are you getting my point?
Yes, sir.
If you are not going to calculate it in kg, then you must have to show that this is moles per gram. Okay.
So sure, so I can write minus 0.001 moles per gram, right?
You can write, but it will be basically it's in general, or by the reference we always do it in kg. So it's better for us to convert it into kg, because in the definition when I taught you, that is written there, number of moles of solute per unit volume of mass of solvent in kg. So we have to convert it into kg. Okay. Are you done with this? Hamza, are you done with this?
Yes, sir.
Okay. So now we are going to start a new topic, that is normality. Okay. So this is basically normality and denoted by n. Before starting normality, we need to clear two term which is very important. The first term is basically equivalent weight or equivalent mass. Nafia, is that what's your name? Wait a minute. Am I audible to both of you? You are not audible. Can you please tell me your name? Hamza, am I audible to you?
Yes, sir.
Now see, before starting normality, we need to know two terms which are very important in normality. The first one is equivalent weight or equivalent mass, whatever you want to call it, just call it. Okay, equivalent weight or equivalent mass. And the second term is gram equivalent. We will discuss after this one. So, what is equivalent weight? So, equivalent weight has a formula, that is molar mass upon x. Now, you know how to calculate molar mass, but what is x? X is known as valence factor or n factor. X is known as valence factor or n factor. This is very important to note that equivalent mass has a formula which is equal to molar mass upon x, and x is valence factor or n factor. Now this is very important to note how we are going to calculate the value of x, because if there is H2SO4 and you have to calculate equivalent weight, you know its molar mass, that is 98, but what how we are going to calculate x, this is important. So I'm going to discuss what is X and how we are going to calculate X. That means valence factor or N factor. First of all, you just write the formula, and then I'm going to discuss what is X, how we are going to calculate X for different compounds. Okay. Nafia, what's your name? Is this your first class?
Sir, it's me, Naura.
Oh, Nora. Why? So you are late. Namira. Nora, actually, after few minutes earlier, I was discussing about the same topic, molality. Yeah, wait a minute. So are you done with this, Namira? Namira, is this your first class? Is this Namira? Nora and Hamza, are you done with this?
Yes.
Hamza?
Yes, sir.
Okay. Namira, is this your first class? Okay, no problem. So see how we are going to calculate X. This is very important. How we are going to calculate X. So see X, I'm going to divide it into three parts. If you are going to calculate X for acid, either acid, if you are going to calculate X for base, and if you are going to X for salt. So this is very easy to understand how we are going to calculate X. See, if it is acid, the compound which you are going to find X for, if it is acid, X is equal to basically number of H plus. That means if it is acid, now see HCl, how many H plus HCl can give? Can anyone tell me how many H plus HCl can give? Nora, Hamza, Namira, how many H plus HCl can give?
HCl can give 1.
1 H plus. If you are going to just dissociate it and just balance it, you will come to know about it how many H plus it can give. So you can see H plus and Cl minus. So basically, if HCl is giving only 1 H plus, equivalent weight of HCl will be equal to whatever is the molar mass of HCl, we can calculate easily, upon X. That means molar mass upon 1. And what is the molar of mass of HCl? Hydrogen has 1 atomic mass and Cl has 35.5. So this will be its equivalent weight. Now going for second example, H2SO4. Just take an example. Now the question is how many H plus H2SO4 can give? How many H plus? Nora, this question is for you, and Namira. How many H plus? How many?
2.
Hamza, how many H plus H2SO4 can give?
2.
2H plus. So if you are going to just dissociate into its ions and just balance it, so you can see this is a balanced chemical equation, and you can see 2H plus it is giving. So equivalent weight of H2SO4 will be equal to molar mass upon X, and X will have a value 2 and molar mass is 98. So equivalent weight of H2SO4 will be 49. So it is very easy to calculate the value of X, the value of valence factor or N factor for acid. What does how we are going to calculate X for acid? X is equal to number of H plus given by acid. Whatever is the number of H plus given by a compound, that will be equal to X. Is that clear, everyone? Now, what is the equivalent weight of HNO3? Just answer me. What is the equivalent weight of HNO3? Tell me what is the equivalent weight of HNO3? Namira, you are not audible.
Sir,
Yes.
which lesson is this? First or second?
This is basically solution chapter, second chapter from first book.
Sir, 15.
Is 15 is wrong. What you just calculated? What you have calculated? Equivalent mass.
Yes, sir.
Okay, 15.
Equivalent weight.
Equivalent weight or mass, that is same thing in chemistry,
Yeah.
mass or weight.
Yes, sir.
Okay. Namira, why are you asking for the chapter? Is this your first class?
Yes.
Okay, actually, okay, no problem. Have you studied this chapter?
Yes. But
Okay.
these things was not there.
Basically, this is concentration term, normality. Okay, Nora, please answer me. Hamza, try it once again because your answer is wrong. Or
2.
2. What is 2? What you are saying? It's about X, or are you 2? You are not audible clearly. You just muted it.
62.
62. So see, HNO3, if you are going to dissociate it, it will be like NO3. Can you tell me the value of X here? 1 or not? X is equal to 1 or not HNO3 for HNO3? For HNO3, X is equal to 1 or not? Hamza, are you getting my point? X
Yes,
is
sir.
equal to number of H plus. For HCl, X is equal to 1 because it can give only one H plus. For
Yes, sir.
H2SO4, X is equal to 2 because it will give 2 H plus. For HNO3, X is equal to 1. And if you are going to calculate equivalent weight is equal to molar mass upon X. What is the molar mass of HNO3? 63. What is the weight of molecular mass or molar mass of HNO3? That is 63 upon X, that is equal to 1. This is basically equivalent weight of HNO3. Namira, is that clear? Now, Nora,
Yes.
Hamza,
Yes, sir.
very good. Can I move to the next part? Base? Yes or no? Have you
Yes, sir, you can.
understood it? Okay, let's move to the next part, that is base. So see, if any compound that is base, X is equal to number of OH minus. That means the compound giving whatever is the number of OH minus given by a base will be equal to X. That means valence factor. If you are going for NaOH, you know that how many OH minus it can give. How many OH minus? Only one OH minus. So X is equal to 1. And if you are going to calculate equivalent weight is equal to molar mass of NaOH upon X, that is equal to 1. If you are going to calculate equivalent weight of MgOH whole twice. So if you are going to dissociate it, Mg plus 2 OH minus. So since it is giving 2 OH minus, so X is equal to 2. And if equivalent weight will be equal to whatever is the molar mass of MgOH whole twice upon 2. Now, can you solve this? AlOH whole thrice. What is the equivalent weight of AlOH whole thrice? Are you done?
This is abnormal masses topic.
What you just said, Namira?
Which topic is this?
This is basically the starting chapter of solution, concentration term, like weight by weight percent, weight by percent, volume by volume percent, mole fraction, molality, molarity, and then it comes normality. This is the last topic of concentration term.
Okay.
From the NCRT, you can check it out. What is the value of X, or you can call what is the value of X for AlOH whole thrice? Anyone? No answer. Nora, Hamza, how many OH minus this can give?
Sir, it can give 3.
3 OH minus, so X is equal to 3. So
Yes.
basically equivalent weight will be what? Whatever is the molar mass divided by 3. This
3.
was the answer I was talking. I was asking about. Is this clear, everyone? Is everyone busy in writing this?
Yes, sir.
Let's see how we are going to calculate value of X for salt. So basically it is very easy to calculate the value of X for salt. We just dissociate it into ions and see either positive charge or either negative charge. Like if there is NaCl, and we know that NaCl is a salt, just divide it Na plus plus Cl minus. And what is the charge? You can either take positive or negative charge. Just don't take it as, with sign. Just take the magnitude. So equivalent weight will be equal to whatever is the molar mass of this divided by X. And X is equal to, basically, you can see +1 or -1. Just take 1. So divided by 1. If you are going for CaCO3, just take it as salt, and it will be Ca plus 2 and CO3 minus 2. So if you are going to calculate equivalent weight of CaCO3, it will be molar mass of CaCO3 and divided by X. X, you can see, either you can take X is equal to from positive 2 or from negative 2, whatever you want to take, but take only the magnitude, not the sign, like +2 or -2. You don't need to write. You just need to write the magnitude and divided by 2. So calculate the equivalent mass of Na2SO4. This is for you. Now please do it, and if you have any doubt in this, I will explain it again. Please write it. Hamza and Nora and Namira, it's very easy to understand. If you have any doubt in this, please ask me. This is the basic part of physical chemistry. You can, if you remember, you studied all this concentration term in class 11th also. And this concentration term is backbone of physical chemistry. Everywhere moles will be used. Molarity, concentration term, that is uh, in chemical kinetics, also in electrochemistry. Almost in every part of the physical chemistry, it will be used either directly or indirectly. So please make sure you are going to learn it very good, because it's the basic of physical chemistry. Are you getting my point?
Yes, sir.
Everyone done with this? Please write it very neat and clean, and let me know if you are done with this. Then again, I will explain. Everyone done with this?
Yes.
Very good, Nora. Namira, Hamza, Nora, Namira, and Hamza. Nora, you are done. Namira and Hamza, I'm asking from you. If you are done with this, let me know. And if you are not done with this, let me know again.
Yes, sir.
Yes.
Okay. Okay, thank you. So see, before starting normality, it is very important to learn two terms. That is, the first is equivalent weight, and the second thing is gram equivalent, number of gram equivalent. This is very important to learn. So first of all, I just told you what is equivalent weight. I'm again going to explain it. Equivalent weight is equal to, if you need to calculate equivalent weight of a certain compound, a specific compound, just take the molar mass of that compound and divide it by x. And this x can be easily calculated. This x can be easily calculated. If it is acid, just see how many H plus it can give. How many H plus it can give, that will be equal to x, and you can put the value of x here and you can calculate equivalent weight. If it is base, you just need to see how many OH minus it can give. Whatever is the number of OH minus, just put it here and you will get your value of x, and molar mass you can easily calculate. Is there any problem in calculating molar mass? You can calculate molar mass of any compound, almost any compound. Namira, Nora, and Hamza.
Yes, sir.
Okay, thank you. And if it is going for salt, you are going to dissociate it, and salt is salt uh, made from which reaction? Neutralization reaction. So it will be neutral compound, and if you are going to dissociate it, you will see a positive charge or a negative charge, like you saw in acid as well as base. But for salt, you can see positive or negative charge, which will be equal. So you either you can take positive charge, only magnitude, not the sign, or negative charge or negative charge. So how here is how we calculated equivalent weight. Now going for the second term, which is very important, number of gram equivalent, number of gram equivalent. It also has a formula which is very easy. Number of gram equivalent is given mass upon equivalent mass. We just learned how we will calculate equivalent weight or equivalent mass, and number of gram equivalent has a formula. This is a new formula, please keep it in mind and write a short notes of this. Number of gram equivalent is equal to given mass, that will be given in the question, divided by equivalent mass, that you can easily calculate. This is very easy. You just need to focus on it and apply step by step, and you will get your answer. So on this topic, I am going to give you a question and see how we are going to calculate. 49 gram of H2SO4. 49 gram of H2SO4, and you need to calculate gram equivalent or number of gram equivalent. You need to calculate this. Please take your time and think about it and do it on your own. Please do it.
One.
That's great. That's very good, Nora. I want answer from Namira and Hamza. Namira, can you do it? Hamza?
No, I don't know.
Okay, no problem, Namira. Hamza,
Yes, sir.
see, what is your answer?
Sir, I'm still solving.
Okay, you are still solving it. It shouldn't take too much time. Just concentrate here. Namira, whenever you have been asked a question, what you need to do is just focus on what is given and what we need to calculate. So it is given that mass of H2SO4, that is equal to, it is given that 49 gram, and nothing else is given, and we need to calculate gram equivalent. So I just wrote a formula for gram equivalent. Gram equivalent. Gram equivalent has a formula, that is given mass upon equivalent mass. Do it step by step and you will get it. Equivalent mass. Now see, given mass, that is given 49 gram. 49 gram is given. So you are going to write it here 49 gram. But for equivalent mass for what? H2SO4, you can easily calculate it. Equivalent mass of H2SO4 is equal to molar mass upon X. Namira, you will answer me. Can you tell me the molar mass of H2SO4? Namira, this question is for you. What is the molar mass of H2SO4? Namira, do you have any problem in calculating molar mass? Hamza, Namira, if you will not speak, then how will I come to know whether you are whether you are getting it or not?
Yes, sir.
What is the molar mass, Hamza? 98.
98.
And how many? Since it is acid, how many H plus it can give, Namira?
2, sir.
2. So it can give only 2 H plus. So what will be the value of X? It will be 2.
2.
So 49 is basically equivalent weight. So we are going to keep the value of equivalent weight, and you will get 1. And unit of number of gram equivalent is only gram equivalent. We write it 1 gram equivalent. Namira, please let me know if you have any doubt. If you are not getting a single point from this lecture, then also let me know. And if you are getting it 1% or 90%, let me know. Hamza, are you done with this?
Can you show how to
Yes, sir.
calculate H2SO4?
Okay, can you show how to calculate molar mass of H2SO4? Are you asking this?
Yes.
So see, Namira, do you know do you know atomic mass? Do you remember the atomic mass of 1 to 20 element?
No.
No. Okay. So okay. Just answer me whatever I am asking. Okay. This is very easy. Namira, can you tell me the atomic mass of hydrogen? Atomic mass. If you know, just let me know. And if you don't know, then also let me know.
Sir,
Do you know?
for knowing molar mass, you have to mug it up, right?
Mug it up.
That means you have to memorize it, right? It's not some
Yeah,
that you
you
can
have
only
to
calculate.
actually, Hamza, it is better for us to remember from 1 to 20, atomic number 1 to 20. After
Yes.
that, you just don't to remember it all. In most importantly, it is given in the question, but sometimes up to 20 it is not given. It should be given, but it is not given sometimes, but most of the time it is given in the question. Okay. This question is for Namira. Can you tell me the atomic mass of hydrogen?
2.
No. Only hydrogen. Hydrogen has atomic mass 1. Can you tell me the atomic mass of sulfur? Yes or no? Just tell me. Yes or no?
No.
Okay, no problem. So Namira, I will send you from coaching. You will get a list of atomic number with atomic mass, and you just have to remember that. That's not a big problem. I'm going to just write atomic mass of this. Hydrogen has 1, sulfur has 2, 32, and oxygen has 16. And now how we are going to calculate molar mass is very important. See, molar mass of hydrogen is 1, but here 2 hydrogen is present. So we are atomic mass of hydrogen is 1, but here 2 hydrogen is present. So we just multiply it by 2 plus. What is the atomic mass of sulfur? That is 32, and only one atom of sulfur is there, so multiply it by 1 plus. What is the mass of oxygen? That is 16. And how many atoms of oxygen is there? 4. So just going to solve it. 2 plus 32 plus 64, and if you are going to add it, 4 plus 2 8, 6 plus 2 8, 6 plus 3 6 plus 3, that will be 98 gram. Here is how we are going to calculate molar mass. So Namira, if you have any problem wherever will be the question for calculating molar mass, I am going to give you atomic mass of each element and in parenthesis for you. Okay. And it is very easy to calculate molar mass. What you need to do is just keep the atomic mass, sum of all the atomic masses, and you will get your molar mass. It's very easy. So please write it, everyone. Just write it. Whoever didn't write yet, and then we will move to the next part. Then I will give you another question. So I'm going to write a question here. 7.1 gram of H2SO4. Calculate gram equivalent, number of gram equivalent. Let me know the answer. Hamza, only you left here.
No, sir.
No, only you are here. Are you calculating it?
Yes, sir.
Okay, please do it. I'll be back.
Okay. So is that 71 or 7.1?
Sorry, it is 7.1.
Yeah, sir, 13.8.
13.8, I think it's wrong answer.
So it should be 98 divided by 7.1, right?
Oh, I gave 90 S2SO4. Wait a minute. Just correct it. You will get a, good number. It is Na2SO4. Yeah.
Okay. Sir, for Na2SO4, what do we divide it by?
What did we do?
Like Na2SO4, the hydrogen isn't there, for example,
So it
for
is
H2SO4.
basically salt. Salt. You
Yeah.
consider it as salt, and you will see if you are going to dissociate it, it will give Na plus and SO4 minus 2. Yes or no?
Yes, it will.
And just balance it. Now it is balanced.
Yes,
Now you
so
can take
we'll divide it by
either
2.
x is equal to 2.
Okay.
Yes. So very good. So gram equivalent, we need to calculate gram equivalent. So gram equivalent will be equal to given mass, that is 7.1. And what will be the molar mass? Sorry,
142, sir.
equivalent.
142.
And what is the equivalent mass? Equivalent mass is equal to molar mass upon x. That
Yeah,
means 2. So
142 by 2.
71.
Yes.
Very good. Very
So it
good.
will be
You
1.
got it. So it will be no, not 1. It will be 1 by 10 now. 0.1. Yes or
Sir,
no?
7.1 into 7 into 1 is 7.1. So we can just write it 1.
What you just said, 7.1 divided by 71 or not?
Yes.
So your answer is 0.1 also. or different?
Okay, wait, yes, yes, yes. I didn't calculate the point. Yes, it will be
Okay.
1. Yes, it will
Okay.
move 1 decimal place on the left.
Yeah. Are you done with this?
Yes.
Now we are going to have the knowledge about normality. So I'm going to define normality. Normality is basically number of, not number. Yeah, number of gram equivalent, number of gram equivalent of solute, number of gram equivalent of solute. Are you writing with me, Hamza?
Yes, sir.
Okay. Number of gram equivalent of solute per unit volume of solution, per unit volume of solution in liter. So this is basically normality. Normality is number of gram equivalent of solute per unit volume of solution in liter. So in definition, it is defined, Hamza, that the volume of solution should be in liter. Now we are going to have a formula for this mathematical equation. Normality N is equal to number of gram equivalent of solute upon volume of solution in liter. Volume of solution in liter. So this is the formula of normality. Now what you need to do is directly number of gram equivalent of solute you have to calculate, and we know number of gram of solute will have a formula, have a formula that is given mass upon equivalent mass, and we know how to calculate equivalent mass. So we are going to do it step by step. If we are going to talk about the unit, unit will be basically gram equivalent per liter, because the unit of gram equivalent is, we take it as gram equivalent. So now I have a question on this. The question is very simple. 49 4.9, I'm going to take 4.9 gram of H2SO4 present in 250 ml of solution. Calculate normality. Calculate normality. Can you do it, anyone?
Is it 4?
Nora 4. I'll just check it out. Nora, Namira, can you do it or?
No.
Okay, Namira, no problem. Okay, Namira.
0.4.
Okay, I'll just check it. Namira and everyone just concentrate here. Here, mass of H2SO4 is given. That is 4.9 gram. And also, volume is 250 ml. What we need to calculate is normality, which has a formula, number of gram equivalent of solute upon volume of solution in liter. Now, volume is given. Volume is given that we can easily calculate it in liter, but here it comes number of gram equivalent. Now see, number of gram equivalent, see, number of gram equivalent is equal to given mass upon equivalent mass. This is the formula, and equivalent mass has a formula, that is molar mass, given mass upon equivalent mass, and equivalent mass has a formula, that is molar mass upon x. Now given mass is, we can easily see given mass is 4.9. Molar mass of H2SO4 is 98. And what will be the value of x? You know that value of x will be 2 because H2SO4 will give 2H plus. So it can be calculated easily. And now if you are going to remove this decimal, 10 will be multiplied and here it will be cancelled, 49, 49. So what we are left with, 1 by 10, that means 0.21. This is the value of number of gram equivalent, 0.1. So I'm going to put the value 0.1 as 1 by 10. And what is the volume of solution? 250 upon in liter, so divided by 1000. So it will be 1 by 10 into 1000 divided by 250. Just simplifying it, 1010, and it will be cancelled by 4 times. 25 4 is 100, and 4 by 10, that is basically 0.4 gram equivalent per liter, or we can also write 0.4 L. Nora, very good. Namira, do you have any problem in this? Please let me know.
No, I understood.
You understood. I am going to give you the same question. You just have to follow the same order and you know to do it. Physical chemistry is about practicing and understanding the different terms or sentences of the numerical. What about you, Hamza?
Um,
Hamza, are you done? Namira, are you done with this? Can I change the slide?
Yes.
Okay, thank you. I'm going to give you another question. 71 gram of Na2SO4 present in 500 centimeter cube of solution. Do you know how to calculate, how to convert centimeter cube into liter? Calculate normality. Everyone done with this? Namira, can you change this? You just have to divide it by 1000. If you are going to divide 500 by 1000, that will be in liter. Can you calculate molar mass of this? I'm going to give you. The molar mass is 142. This is for your hint.
2.
2. Who said 2?
Nora.
Nora. Very good. Hamza? See, I'm going to explain it again. So it is given that mass of Na2SO4 is 71 gram and volume is this much. Now see, normality has a formula, number of gram equivalent upon volume of solution in liter. Volume is given as 500 centimeter cube, so it should be in liter, so divided by 1000. Now, number of gram equivalent has a formula, that is given mass upon equivalent mass. Given mass is 71, and for equivalent mass, I am going to find the formula. Equivalent mass has a formula, molar mass upon x. Molar mass is 142, and x, for x you are going to dissociate it, take it as salt, and it will be 2Na plus or plus SO4 minus 2. So basically take negative or positive charge, x will be 2. Because here it is plus 1, but multiplying by 2, it will also be plus 2. So x is equal to 2. So the equivalent mass is 71. Just put it here, it will be 71. So number of gram equivalent is 1. Here is number of gram equivalent 1. Just simplify it. This 1000 will be in numerator, and this will be 500, and you will get your answer 2 gram equivalent per liter, or 2N. Please write it. Please write it and let me know. Namira, how many chapters you have covered in chemistry?
2.
2 chapters. Solid state and solution, right?
No, solutions and haloalkanes.
Hello, okay. So have you completed the solution chapter?
Yes.
Okay, and you haven't studied any concentration term?
No, but this gram equivalent was not there, I think.
Okay, normality is not there only. Okay, have you bio or maths?
Bio.
Okay, so this basically it is important for NEET, or it can also be used in many physical chemistry chapter. So that's why I teach it. It's very important for NEET. Hamza, Nora, everyone done with this?
Yes.
Okay. Tomorrow, in tomorrow class, I'm going to start solubility, and then Henry's law. These two. And before starting this, please make sure whatever is your doubt in concentration term, in molarity, molality, and normality, please ask me. And homework is that you are going to solve in-text question from 2.1, 2.2, 2.3, 2.4, and 2.5. These all in-text unsolved question from NCERT is on the basis of concentration term, which is very important. Please do these 5 questions, and I will see you tomorrow. Okay, Namira, Nora, and Hamza. Okay, everyone. And the class time is basically 6:30, so please be on time. Am I audible to all of you?
Yes,
sir.
sir.
Okay, thank you so much for today.
Thank you, sir. Assalamu alaikum.
Walaikum assalam.